Hi Jacob, thanks for your question. If we want to go ahead and solve for the remaining factors of this polynomial here, it's very, very helpful that they've given us one root to start with, because what we can do is we can use synthetic division to divide out this root. So they told us that x equals -3 is a root of this equation, which means that x plus 3 is a factor of this equation. As you can see, if I plug -3 in here, I would just get 0. So let's go ahead and set up a synthetic division problem where we're dividing out -3. So the coefficient of this first term here is just 1. Coefficient of the second one is 1. Third is -3. And the constant is -9. This is where my remainder is going to be. And I should end up with 0 if this is in fact a root. Let's go ahead and drop down this first term, multiply, and we'll put the product up here. And we are going to add, multiply, and put the product up here. And we are going to add, multiply, and put the product up here, and then add down. And yes, we did get 0 for our remainder. So this is indeed a root, which means that this equation factors into x plus 3 times, we're going to reduce the degree of the exponent by 1 and input these coefficients. So this will be x squared plus 0x minus 3. Once we've reduced it to a quadratic equation like this, unless it's an irreducible factor, we can reduce it again very easily. This happens to be a difference of squares. It is x minus the square root of 3 and x plus the square root of 3. So the remaining roots of this equation are, let's set this equal to 0. X minus the square root of 3 is equal to 0, means that x is equal to the positive square root of 3. And x plus the square root of 3 equals 0, means that x is equal to the negative square root of 3. So the roots are x equals plus or minus the square root of 3. And those are all of the roots of this equation. We know that they're all of the roots because there are 3 of them, and this is a third degree equation. So thanks again for sending your question, Jacob. This was a fun one. I look forward to answering more of your questions using SnapMath in the future.